Hi everyone, how you doing? Let's keep going with the mini map class. So in the last class, we already set up the widget, didn't we? And in that class, we arranged it here with the binds to help us organize things. Okay, and this is the one that's about the opacity. Okay, so this one is for the opacity, and here we created the function where you can press the map with the M key on the keyboard, right? And it calculated the proportions of the image file and arranged it in like a little window in the corner of the screen. So it kept it in the proportions that we wanted, and it took into considerations the ratio of the original image. So for now, we have the map. Now we will insert our icon, which will represent the first person. Okay. Okay, so to make it easier to visualize, what I'll do is I'll put the floor plan image here, just so we can visualize it. Okay, and I'll leave it large like this. Okay, I believe that's 1712 by 606. Right, so that's the size of the original image. I'll leave this here just to make it easier to explain. Okay, so now I have to add an icon, which is going to represent the character, right? And this icon will simply be an image, but it'll represent where we are in the scene. So let's just put one here on the canvas, and I'll name it first person icon. There we go. So it's an icon for the first person. And I'll also need to align it as well. And I'll adjust to 0 and leave it centered. Okay. So what matters is the center icon, right? And it'll be centered here with the anchor positioned on the upper right corner. Okay, so I have an image. Okay, and I can add this image here, which is going to be our, uh, it's going to represent our character. And you've got this angle here that represents the field of view. So if you've got an image that you want to use, then feel free to do so. That's just what I got. So I'll put that here. And as you can see, it's already on the map, right? I'll set it to 30 by 30 in its size. Okay, and 30 by 30 here as well. Okay, this doesn't obviously matter too much, but you can leave it here or here. It doesn't really matter. As long as it's 0.5 by 0.5, then that's all good. Okay, and I'll make it black. Maybe a bit grey, actually, not too dark. Okay, so let's put it around here. Just check the proportion within the scene so it's not too large and it's not too small. You can make some adjustments if you need to. And down here, this is also adjustable, so you can set it according to the size of your project. Okay, so now we have to talk about the concept of its positioning and how all of that works. So we have the challenge of making this map become or scaling properly, right? So it needs to be the correct scale to our real scene. Okay, so for example, if we went into top view here, this is our project. Okay, so let's change it to unlit so we can see it in that mode. There we go. So we have the garage, we have bedrooms, we have living rooms, and we've got the pool at the back and the wall. This is a little bit different around here. Obviously, it's not completely finished, but that's okay. At least we have like the perimeter, don't we? Okay, so we have a distance from here to here and another one from here to here. So this is a real distance from here to here. So what do we have to do? Well, what we have to do is we need to calculate what the scale factor is. And that allows me to get the size, the measurements from here to there. Okay. So since this floor plan is ready, it's already in the right proportion for our scene. We don't need to worry too much about it. Okay. We only need to find out the scale factor. Now, let me ask you, why would we ever need to worry about the scale factor? Well, that's because when I need to move my character, I need to find out if it's here, for example. If it's here, how many meters in the real scene are represented in pixels here? Okay, so I need to work out how far the distance is between my character being represented on the map, between different items or objects in the scene. So we need to scale it so it's relative to the real world. So how do we do that? Let's go back to our whiteboard again. And let's just suppose that we have a rectangle as our real world floor plan. Okay. And we'll just call this real. And now we need to transpose the real scale, or transpose its scale to the minimap. Okay, so we have to find out the scale factor from the real size to the minimap. So let's suppose I've got a measurement here of 100, and here I have 100 meters, okay, and in my minimap, let's suppose I've got 10 pixels. So to find out this scale factor, what calculation should I do? Well, I must get the minimap width and divide it by the real world width. So that's 10 pixels divided by 100. And this equals 0.1. Okay? So having this scale factor, I can find out then how much each meter is equivalent to in the minimap. I can find out this with the multiplication. So I have to multiply 1 meter by the scale factor, which is 0.1. And what does that equal? It equals 0.1. So for each meter, 0.1 pixels would represent the meter. Okay. So let's suppose I have, let's say 10 meters. Well, that's 10 times 0.1 equals 1. So each pixel represents 10 meters. Okay. That's how scale factors works. Now, you're probably used to it with floor plans, but I wanted just to show the logic here on the screen so that anyone, no matter what your background is, might find it easier to understand. So we need to see how we can do that within Unreal. So we need to get the width of the minimap, which is called the window width, and then we need to divide it by this measurement here. Okay, and at the moment I don't know what that is, so I need to find out what that is. And in Unreal we will always work with coordinates. So let's suppose I have a coordinate of, say, 10. Okay, let's suppose 10 is my coordinate here, and I have a coordinate of 110 there. So to find out this distance, what do I have to do? Well, I have to take this coordinate and subtract it by the initial coordinate. So it's 110 divided 110 take away 10, and that will give me my result, wouldn't it? Okay, and that means that x equals 100. So first I need to calculate this distance, this range here, and then divide it. Okay, and I'll call this Rx, or range in x, and I'll create a variable for that, and I'll get the variable that is the window width and divide it by the range, and the result will be the scale factor in x. Okay, make sense? Cool. So in an ideal world, you wouldn't need to calculate it, and you wouldn't need to calculate the scale factor for y, because if the project is in proportion and so is the minimap, then you don't need to calculate it. But I'm just going to do it so we understand how scale factors work, and I'll do it in y as well. Because maybe there might be some variation, like a floor plan that might be out of proportion. It's just to make sure that the character is going to move without any issues as well. So to find out what the scale factor for y is, what do we need to do? Well, to do that, we need to get the window height. Let's call it a window height variable here. Okay, so that's the window width here as well. So we need to divide the height by the range in y. and then I'll divide here and get both scale factors. Okay, and then what am I going to do with this information? Well, later on, I'm going to tell the character, the icon that we made, that for each meter that the first person walks, we'll need to multiply it by this scale factor. And then the icon will walk here and it will keep in the correct proportion. Okay, so that's the theory. Let's go now and do it in practice. Okay, and then we will explain as we go along. So the first thing we need to do is, just as we said, we need to find out what the range is between our width, okay, the distance, the Rx and the Ry. So that's what we first need to work out. So we already have the height and the width from the window because we already have that stored in variables. Having the range, we can find out our scale factor and then we'll move on. Okay, so the first thing is to find this out. We need to find out the distance from here to here. Okay, the simple way is to measure it. So how do we measure it? Well, we drew the projects and we have the measurements, didn't we? So we would only need to get the distance from here to here. You could get that from your original model if you know the size, okay? Or what you can do here, let me just show you. When you reuse a blueprint for another project, actually, yeah, it's good to show you this way. When you reuse a blueprint for another project, you'll need to do these measurements again. So let's avoid this amount of work and make it more automated, okay? So there is a resource in Unreal that will help avoid having to repeat things in new projects every time you set this up, okay? Which makes marking spots really easy on the ground, okay? It almost like it registers the coordinates. And the name for this is called target point. Now you may have seen this, but here it is. It's in Actors. It's called target point. And I'll put a target point here. See its name? Okay. And I can come close in here as well. So whenever I put this target point in the scene, it's going to show a coordinate in X, Y, and Z. Okay. So whenever I put it, or wherever I put it, it will mark the spot. So what can I do with it? Well, I can put a coordinate in each corner. Okay, and I can ask Unreal to calculate this for me. It's so much better if I ask Unreal to do it than trying to do it myself. So let's put it in the scene. Okay, and I put it in there in the corners. This one there, and put it here. And I have a marking in the X and the Y axes now. And if I put another one here, it will show another X and Y marking. And then that provides the range of Y and X. Okay, creating a rectangle for me. There is a little bit of detail just to be aware of. That makes it different from 3D's other 3D programs that we might have used. And for example, in 3ds Max, Y points up, right? And X is to the right. So things go from the bottom up and from left to right as they increase. Now here in Unreal, it's a little different. In Unreal, things grow from top to bottom, okay, and left to right, just to confuse things. So if you're looking here, it's -760. If I drag it down, the value increases, and vice versa, okay? So it's probably better to work with a 0 point in the upper left corner. And if you do that with the 0 point here and another pivot or another point target here that we can calculate, that might make it easier. Okay, so I put it here and use 0 in coordinate Z, so it's not too far away, and I put it on the farthest corner as well, in the furthest corner in the scene. Okay, so preferably in the furthest corner of the floor plan or your map, and then it'll be in proportion. And I think I used the wall to align it as well. It doesn't have to be super precise. I'll measure it as best as I can. Bring it here. So where these lines meet, which is -700, I put the target here. And then I'll create another one on the opposite corner. Okay, so just around here, just there, I'll type in to make it easier, 337 by 120. Okay, so I've got those target points now. So what do we do now that we've got them? Well, what we need to do is get this and pass it to the blueprint to create a variable with it. So I need to go to the event graph and go to construct and make a reference from this. So I get all actors of class, and you can type target point here. Okay, and I'll get a copy as we did before. Okay, so that's going to give me an array as well. So the first item is 0, so it allows me to, it always follows the order in the scene, so that helps me that way. And there is this thing here you need to pay attention to. Since we're building our blueprint with the basic workflow or idea of using the upper left and lower right corners, with that in mind, we have to follow this order when working on other projects. Okay, keep it the same. So the first target point has to be at the upper left. The second one has to be at the lower right corner. Okay, so this is 0 and this will be 1. The second one will be inserted into the scene. So 0 is here. I'll promote it to a variable and I'll name it target. And it's the upper left one. So it's target upper left ref. Okay, so it's the reference for my target point in upper left corner. And I'll get the another copy for the second one, which is number 1. Nice. This is easy, right? There's nothing new here, really. I'll name this now. And the other point is on lower right. So I'll name it target lower right ref. Cool. Link them together. Nice. So I created the 2 references here then, but this is only a reference. So what do I need to do? Well, I need to get the coordinates from them and then store them in a variable to work with the values later on. So to get a position in Unreal, there's a node called get actor location. Okay, and it's the location of the actor in the real world. So now we've got that. I need to promote a variable. Promote to variable. There we go. And I can name this UL position. Okay, with the position of the target point, connect them. And the same thing with the other one, get actor location, promote to variable. And this is LR position, be in lower right position. Okay, and then we can link these. Nice. Compile, save. And then let's see what it's doing. I'll add a print string to make sure it's actually understanding. Probably need 2 actually. I'll put here 30 seconds so we can see it on screen for long enough. Connect those. And we need to create another one. And we'll change its color as well so we can see the difference between the 2. There we go. So just so we can visualize what we're doing when we press M. Okay, so I press M now. Great, but it's not showing. Okay, so why is that? Oh, I think that's because to record the video while using Unreal, it might not work. So I had to reduce the resolution. Okay, so now it's showing that texture message. So I had to disable it and enable it. Okay, so let me just go back because we did it too fast. So here I open the level editor, level blueprint, actually, which is R2 underscore main level day. Okay, that's the level, which is the open level and the open level blueprint. So what I had to do is I had to create 2 console commands. And what does it do? Well, we have a console command down here, right? You've already used this before, I'm sure. CMD. But you can just type in your console commands. You can actually do that in blueprints as well. So we can type commands and functions, and we can do them via the blueprint in case you want something specific to happen, maybe while you're testing things out, or you want to disable certain features. You can do it on there. Okay, so you can use the execute console command. You can put any command in there really. So I entered disable all screen messages to avoid messages from disturbing us, and I'm returning it if you disable it. So there is a use to this sometimes to disable it, but we want to enable them because we want to see the messages on our screen for a print stream, right? For example, other messages show up as well, such as text to streaming, but that's probably because of how the project was set up. But now we can see in the blue and the red, we can see the values showing up. Okay, cool. So the message in red is the lower right position. Let me just go back, and that's this guy, right? 337 by 120. And the upper one, let me just get it. So the upper one is minus 700 by minus 320. So let's take another look. There we go, 700 by minus 320, 3375 by 120. So that means it worked. So what we did was simply store these coordinates of these two target points in our blueprint. Now, how cool was that? It simply stored the coordinates for us just as we intended. Okay, so what we'll do now is we'll then work with these coordinates, right? So I can delete these for now. That was just to show us what we're doing, and I can comment over this, and I call it get target point position. Okay, nice. So that covers the target point positions and the references. Good stuff. I'm really pleased that that's working. So what we'll do now is we'll get the range, which is what we really wanted, wasn't it? The RX and the RY. So we have these coordinates, and now we'll be able to calculate them now. So the best way to go about doing that is I'll subtract this coordinate from this one. Very simple calculation. So we'll start with coordinate X. So to get it, let's get it from, it's this point here, right? So this one in the lower right minus this one here. So that's lower right minus upper left. Can you remember that? Lower right minus upper left. Let's go and reproduce it now. So back into Unreal. Lower right and upper left. So I've got both coordinates here. And now what I can do is I only want X, so I just have to open the coordinate, open the position. I only want the X part, so I'll subtract this one from X. Let's go subtract, plug them in. And it will store this in a variable called range X. Okay, let's name it range X. Nice. Okay. So now I'll do the same thing for Y. And what's the idea for Y? Remember we said that the 0 is here, and Unreal increases from top down and from left to right. So I got it from the right to the left, and now I'll do it from bottom up in Y. So it's lower right minus upper left, and store it. Okay, cool. Now it might look complicated, but it's not. Okay, so it's once we get our head around it, it's even more. It makes even more sense. Simple calculations, really. So I'm just reproducing what we saw here on the whiteboard in the blueprint. Of course, it would be easier to type it, okay? But that's not the way blueprints work, is it? So if you were creating one mini map for one project, it'll be easier to type it and then that'll be it. But after you do it once and then you migrate it to another project, set the target points, and then everything's done for you. You don't need to do this every time you start your project, okay? But understanding how this is done will really help. Let's create a sequence here so we can, make sure that they are working in sequence. This goes here and this one comes down here. Nice. Okay, so this one will only get the range, and I'll comment get range X and Y. And this range is the distance. Okay. So that's the distance. It's the size of the project from here, which is X, and from here, which is Y. So we have X and Y ranges. Great. Let's go back to the board. So we have Rx and Ry. Now we need to find out the scale factors in X and Y. Now remember that if the floor plan is exactly in the same size as the project, one scale factor is already enough. And you can use the same scale factor for both. But we'll do both just to avoid any problems, okay, that might happen. So what we'll do now is get the window width, okay, following exactly how we planned on the whiteboard. We'll get the window width and we'll divide it by the range of X to get the scale factor, and then we'll store it in the variable. Okay, now let's do this. Okay, so the first thing we need to do is get the window width. So where do we do that? Let's go into our blueprint. Yeah, not here. Let's take our blueprint. So there's our blueprint reference here. And I need to get this variable as well for the window width. Get window width. And I need to divide my range in X. So I need to type in here divide. And I need to get range X. There we go. Nice. And I'm going to promote to a variable from here. And I'm going to name this one scaling factor X. Cool. And I'll link this here. Nice. And let's just move it over a little bit. Keep it tidy. Okay, and the same thing for Y. I'll get the window height. There we go. And then I'll divide it by range Y. And put it in a variable named scaling factor Y. Okay. Cool. So I created the variable, moved it here, and it's going to store it. So now I can comment, call it get scale factor. Okay, nice. All good so far, right? So well done for following to this stage. We're almost there. So we have the scale factor in X and scale factor in Y. Okay, so what we need to do now is get this scale factor information to move the icon in the widget. All right, and we'll take a look at that in more detail in our next class. Okay, let's keep going. See you in the next class.